Thank you, Caleb, for the introduction, and a shout out to our sponsor, Bogdan. He was at AlphaCube, which is an investment management company based out of Dubai. So, what is Solana, and why are we focusing on Solana? So, we've heard a lot of talk today about crypto and the volatility in the crypto space, and why exactly Solana? Because Solana has a higher speed than other crypto platforms like blockchain and Ethereum. And just to give you an example, on Bitcoin, the number of average transactions per second is about 7. On Ethereum, it's a couple of hundreds, but in Solana, it's a few thousands. And on the flip side, if you look at the average transaction cost, on Solana, it is only about a fraction of a cent, while on Bitcoin, it could range from a few dollars to a few $100s. Now, that creates a great possibility of high-frequency trading, automated bots, and sniping strategies. And consequently, Solana has become a hotspot for meme coins and pump-and-dump strategies, which we'll try to look at today. And we can just dive into our project.
So while Bitcoin focuses on being a digital currency and Ethereum on smart contracts and being friendly for developers, Solana's niche, as Rish said, is having really low fees and really high transaction processing speeds. So when we first started our project in September 2024, Solana could process 2,400 transactions per second with fees as low as 26 hundredths of a cent. And if you compare that to Ethereum at the time, Ethereum could only process 15 transactions per second, and with fees over 1,000 times greater than Solana at 30 cents on average per transaction. So yeah, what this means is that Solana is the perfect space to have a lot of transactions and to launch coins really cheaply. So the next piece of the puzzle is understanding automated market makers. So what an AMM is unlike on a traditional exchange with bid and ask spreads, it's operated and the price changes according to a formula. So the formula is the amount of Solana in the pool times the amount of the meme coin in the pool is equal to a constant K. And this means that when the AMM starts and the liquidity pool opens, the meme coin is pretty worthless because there's a relatively low amount of Solana in the pool. And with every transaction, with every person that buys that coin and puts in Solana, the price increases exponentially. So when you combine all these factors, the AMM, the exponential price increases, and the cheap and fast transactions, it's the perfect spot to launch a meme coin and execute a pump and dump.
So how do we analyze all these transactions? So our main goal for this project is to classify all the transactions into two big groups, market makers and organic traders. We want to see who the market manipulators are. And meme coins, if you check on SolScan or DexCreator, which are some analytical tools, you'll see they have highly manipulative trading patterns, are huge. As projects already mentioned, about 95% transactions or 98% transactions are only market makers, and about 2 to 5% are organic traders. So for this project, we were looking at two specific meme coins, Wooly and Foon, which were given to us by our sponsor. And there were a total of 8 JSON datasets, 2 from Foon and 6 from Wooly. The Foon dataset was from 17th of September 2024, and the Wooly was from 18th of September 2024. And on the right is a small snapshot of how that JSON file, when converted to CSV, looked like. It had some flags. It will give you the Solana change for every transaction, the specific token address, and some flags, where it was executed. Was it executed on Radium? Or was it a Radium liquidity pool creation activity? What kind of SDK was used? If you don't know, SDK is a really significant factor on determining if it would be a market maker transaction. We used two broad approaches to get to our classification. I specifically worked on machine learning approaches, focusing on anomaly, clustering, and rule-based scoring to get on to determine thresholds beyond which I would classify that as a market maker. These approaches usually focused on behavioral patterns, the amount of absolute Solana changes, what kind of flags were raised for every single transaction, And I finally used a top K rating to classify the 5% as market makers.
And my approach was data mining. So at a high level, my algorithm starts with randomly generated rules based on features of transactions. I combine those rules into formulas, and then I go through a series of gates to end at a risk score for liquidity pools and assess how at risk they are for a pump and dump. So my rules are a combination of numeric and Boolean. So my numeric rules are using a quantile approach. So for example, one rule might be the time since pool created is in the 95th percentile. And then my Boolean rules are obviously true or false, and these are mostly based on the specific AMM platform that the token was launched through. And then I have formulas that these rules are combined into. So the formulas are a combination of numeric and Boolean. And these formulas, so their goal is to capture between 95 and 99% of transactions. So market makers, as our sponsor said, account for about that much of the total transactions on Solana. So as many as 99.9% of transactions on Solana are artificial, are bots, and are done by market makers. So my rules and my formulas are trying to capture that sort of space. And the ones that they don't capture are going to be classified as organic traders. So once I achieve formulas that have captured 95 to 99% of transactions and I throw out the rest, then the next step is to look for behavioral outliers. And specifically, I'm looking for outliers in terms of total organic pressure. So what that means is organic Solana change. And this matters because when a pump and dump is executed, it can only be done profitably if there's enough outside Solana that has gone into the pool for the original holders of the coin to get out profitably. So the timeline is the liquidity pool opens, the early holders get in, some bots go through and do some artificial transactions. This gathers retail trader interest. Retail traders buy the token, put a bunch of Solana in, and then it's rug pulled. The original holders sell their holdings, and it crashes. So can you go back? Sorry. And the way that I detect these outliers is through the mean absolute deviation based z-score. And this sort of highlights cases where a disproportionate amount of Solana is held by a few liquidity pools and not by others. So the liquidity pools in which there's a lot of organic pressure, a lot of organic traders are putting in Solana, these are the ones that are at risk. These are the ones that are at risk. The ones that no pressure are at no risk for a rug pull because it can't be done so profitably. So I had a few challenges over the course of my project, and the first is that results were, sorry, yeah, okay, I'm gonna start with, never mind, I'm gonna go back to this. The first is that the results were highly subject to the number of transactions that there were. So there were a lot of, so there were cases that I didn't put in that were, sorry.